Another type of algebraic operation you need to be able to deal with vectors is an operation known as the scalar or dot product. The reason why it's sometimes referred to as a dot product, as you can see by the operation that we're going to be performing, right, highlighted here in red, there's a dot in between the two vectors. The reason it's called a scalar product is if you take a look on the left-hand side here, it's not bolded, we're going to be left with a number. Now what this thing basically does is it takes one of the vectors and multiplies it by the part of the other vector that points in the same direction. So basically it's used to multiply vectors together by multiplying the parts of them that point in a straight line together. Now, it gets used for a lot of different things. We're going to use it to calculate energies and whatnot. So what we're going to do is we're going to talk about how to perform it. As with every other bit of math in this class that pertains to vectors, you really want your things into Cartesian notation. You can do this in an angular notation. However, in order to multiply vectors in an angular notation, you need to find the angle between them. And it's very slow to do so. In fact, it's often much faster to simply convert all your vectors to Cartesian notation and then just perform the dot product with this procedure that I'm going to show you. Now, the idea here is we're multiplying parts of vectors that point in the same direction together. If you take a look at your vectors, if they're in Cartesian form, there are two parts that point along the same direction in terms of x, and there's two parts that point along the same direction in terms of y. And we're going to take advantage of this to multiply it together. The idea being is in order to find c, we're going to basically multiply together parts that point along the same direction and then add them all up. So if we take a look at the x parts, the first x part is 2, the second one is negative 3, and we're going to multiply these together because they point along the same direction. We're then going to add this to the other 2 points that point along the same direction. So 3 for the y component of A and 4 for the y component of B. Now the nice thing about this is it yields us a scalar number, so when you multiply these out, you don't really need to worry about what direction they're in. 2 times negative 3, negative 6. 3 times 4 is 12. If you add these together, your final scalar product is 6. And that's basically all there is to deal with or to do when you have to deal with a scalar product if you're in Cartesian notation. Again, it goes along with our things are usually a lot easier to deal with when they're in Cartesian. Now, you could do this in angular form. There's nothing stopping you, but this is the method that I would recommend that you use every time that you see it.